Alright, welcome back. We got another project for you today. We got our dyno with us and some new things we're going to work on, but at first I wanted to show you my Cloak of Invisibility. Let's see if I can get this to work. I'll put my cloak on here. Check that out. Awesome. Oh, my shoulder over there. Hey. Anyway, let's get started. Today we're going to be working with tilt switches. So let's move on to the other screen. Here we go. Oh, it's chopped off a little bit. Let me make that a little smaller. Maybe I'll slouch back here a little bit too. Alright, so here's the parts we need. The tilt switch is right here. Kind of looks like a capacitor. We actually haven't used capacitors yet, but it kind of looks like one of them. But it's not. And you're also going to need two LEDs. Pick a color of your choice. You need one resistor that's at least 1,000 ohms. I can't remember exactly what you have in your kit. I think you have 1,000. 5,000 would be better. But somewhere between 1,000 and 5,000. And these are going to go with our LED. So these need to be 220 or 330. I know you have both of those in your kit. And of course our Arduino here. And these tilt switches are pretty cool. They're how do I explain what they do? They're basically, imagine like this is like a little canister, like a empty soda canister inside of here. And at the bottom, there's a conductive little ball at the bottom. And if you know you got the right part, because if you like jiggle it around, you can hear the little ball bouncing around inside this little canister. And so when the ball is at the bottom, it's being conductive and it's allowing the switch to be on, so the current can flow through the legs. And when you tilt it about, we'll find out because we're going to have the lights help us, but at least above, right about there I hear it clicking at the top. Yeah, right there. So when it rolls to the top, it's no longer connecting the two wires, so then it's an open switch. So we're going to go ahead and try this out today. And let's wire things up. We'll do what we normally do. We'll just get this to work, and then we'll add some things to make it do something a little more interesting. Alright, so I'm going to move these out of the way. I'm going to need, actually we need that. Let's move the LEDs out of the way, move them over to here. Move my resistors, they're going to go with my LEDs. And then let's start off with this. And I'm just going to place them right here. We don't care which side is which. Oh, we got a little wire sticking out. Right there, poke me. A little wire sticking out. Let's try it again. Alright, looks pretty good. And one end of this tilt switch we're going to send to our ground. No surprise there. So I'm going to send it all the way over here to ground, like that. The other end is slightly more tricky because we need to have a pull-up resistor. We're going to use this as our pull-up resistor. This is going to help our switch to stay on and off. So even before we do that, let's do one more thing actually. Since we're going to be introducing our LEDs in a moment, instead of running my ground over to here, I'm going to need more ground later. I'm going to move this back to this. Matter of fact, I'm going to grab a tinier one. That's a long wire. Just pull that back out. Man, it's tough to push in. There we go. And make that the negative side. And then let's find some tinier ones again. Then we'll make one here and go like that. That'll work. So now I've got this whole blue rail as my ground. And let's do the same thing with the 5 volt. We're going to need that eventually. Don't have a lot of color options in front of me here. Alright. So I'm going to take the 5 volts. Pretty standard here. Kind of do this every single time. Not totally necessary unless you run out of grounds. In this case, we're going to run out. So, alright, so I put that in the 5 volt. Put in this rail. So anything I put into these is going to have a 5 volt source. Alright, now let's go back to the tilt switch. And there's my resistor. I need my 1000 ohms. Between 1000 and 5000 works great. We're going to take this and go from 5 volts, and I'm going to run it all the way over to where my switch is. Right there. Okay, so this side of my switch is going to go through the resistor and into this 5 volt source. This is going to be my pull-up resistor. And I'm also going to take another wire. This is going to be my signal wire to let me know whether this is turned on or off. And I'm going to just pick one of these digital pins. And let's pick 13 since it's on that end anyway. So I've got it in 13. Alright, so basically I'm going to be getting a signal from my switch. It's going to be either on or off, and that information is going to flow through here, and pin 13 is going to pick that up. Alright, let's go to our code and get this to operate. What we're going to do is basically just take a look at this switch turning on and off, and then we'll do something with it. So we want to look at it. We want to get some feedback from it. So we're going to do serial print begin. That looks good. We need to grab information from this switch. So I need to make up a variable again. I'll make this slightly bigger. I had some people say they couldn't quite see. So let's increase font size just a couple sizes. Let's do one more. That looks good. Alright, I was back up here. We're going to make a variable that we can stick a value in from our tilt switch so we can see what it's doing when we turn it on and off. So I just call it, how about tilt switch, capital. Alright, tilt switch. And then we'll jump down here, use that variable we just named, and then we're going to get some information from the tilt switch through this yellow wire. So we're on the digital pins. We want to use digital read, and we're in pin 13. Alright, we need to tell the Arduino that we're going to have incoming information from pin 13. So I'm going to make that an input. That looks good. And let's take a look at it. Serial print, we're going to take this information from where? We're going to take it from what we're reading from pin 13. And take a look at it. Now I don't really need a delay. I don't care if it's really fast, because I'm only going to have a 0 and a 1. I can see that probably pretty clearly on my serial monitor, so let's not worry about delay. This is probably all we need, which is kind of cool. We don't need a whole lot of code for this. Okay, so let's upload this. Whoop, I uploaded it before I plugged it into my computer. So let me go back and do that. I need this. Let's go ahead and cancel that. Cancel that order. Plug this in. That looks good. Make sure the port, which it found already, and the board it found already, don't want it to actually switch a new one, so let me click up there. Alright, now let's go ahead and upload. Done uploading. That's pretty fast. That's good. Last video I made, it was kind of slow. Alright, got a bunch of zeros. So now let's give this a tilt and see what happens. Hopefully when I get halfway here. Alright, nice. I heard a little click. That little ball that's in there, conductive ball, and now slid to the top. And on my serial monitor, it now switched to a 1. That's fabulous. So I'm going to toy around this just a little bit. We got a 1 when it's tilted and a 0 when it's not tilted. It's a pretty good signal there. Alright. Now I want to point out something else. Since it's just a ball in there, I can actually, if I tap the breadboard, I should be able to get it to turn off just briefly. You see a little pulse just for a moment. We're going to use that. We're going to toy around with that too when we add these LEDs. And just for giggles here, I want to see what this looks like on serial plotter. Yeah, there we go. That's cool. My little taps. Kind of like a crude seismograph here. But still just doing on and off. And notice it's kind of cool. I could freeze this somehow. There's no pause here. That's good enough. Alright, let's add. And that's cool. We need to do something interesting. We're just going to hook this up to some LEDs. I'm going to do the red one here. Got to keep in mind that we care about the long and short length part. The long lane needs to go to positive. Actually needs to go to the signal that's going to tell this thing to do something. So I'll put that one here. And I got my little resistor, my 330 or 220. And I'm going to send that over. Well, let's do it the other way around. Doesn't matter which side I put it in. I'm going to put this in the negative side, and so I can save myself a wire. We'll have this straddle all the way over to the negative side of our rail here. Then I'll just use one wire. Well, I think I found the broken wire. Throw that one out of the way. All right, let's grab this one. The other side, the positive side, we're going to be sending information to our LED. So let's pick another, basically turn it on or off this time, depending on the position of our tilt switch. So let's put this in 7. And let's go ahead and pause and go back to our program. And I would like it to turn on when I tilt it. Actually, I'm going to switch colors because I think I want it to turn green. So I'm going to just switch colors, make that green. I want to say, hey, you've tilted, and so we're going to indicate that with the green LED. All right, so we're going to use the if statement, and we're going to check to see what the value of the tilt switch is. Is it 0 or 1? So we need to look at that variable. So tilt switch. And since we're checking, we need 2 equal signs. Remember, 1 equal sign is we're assigning whatever we get from 13, pin 13, we're assigning it as this variable tilt switch, what's an equal. Down here, we're checking to see if it's a 1. If you remember, we tilted it, we got the 1, so that'll work. And then what do we want it to do? We need to put that in brackets. Well, we want it to turn on the green LED, so we got to do a digital right, and we're going to make that 7 was the pin we used. We're going to turn it high, and we should probably turn it off once we get out of this loop. Once it's no longer a 1, we need to turn it back off, or it'll just turn on once and stay on. So outside of the loop, let's go ahead and turn it off. We'll do that with low. That looks pretty good. And let's help out our Arduino and help it by saying pin 7 is going to be an output. If you don't do this, then your LED will be very dim. Technically speaking, I don't think we need the input pin. I think the default is input for all pins, and you have to say output, but I oftentimes can't remember. It's a lot to remember, so I just usually just put them in. So it's not going to hurt us if we put them in. Alright, I like what I see. It looks pretty good. Let's go ahead and upload this and give it a try. Little dyno break here. Compiling gods are with us today. It's a really short time. That's good. Let's open this up so we can kind of see what's happening. We're at 0, so we don't expect anything to happen. And then we'll do a little tilt. And our light did not go on. We went to a 1. But our LED did not turn on. So let's see. What could be the problem? The wiring could be bad. No, I did not plan this. But this, troubleshooting is excellent practice. Could be our wiring, could be LED is bad, could be our code. One of those three things. So let's take a look at our wiring first. Actually, the quickest thing to test would be the LED. I'm just going to pull that out and put in a red one and see if it still goes on or off. Right, tilt it. It did not go on, so it's probably the wiring. So I'm negative here. I'm going into 7. And we got a mystery here. Let me take my glasses off and take a really close peek at this. You probably, okay, so just flickered back on here for some reason. We got a flicker. So we got a bad wire? It's on. We shouldn't be on at this moment because we're getting, hold on a minute, we're getting 1s on our monitor here. I kind of want to stay on so I can figure out what's wrong with this circuit. What I'm going to do is just bypass the 7, and I'm going to go directly into the 5 volt here, and it's on nice and bright, so that looks pretty good. So my wires, at least this one was good. My circuit is good up to that point. This wire could be doing something funny. I'm going to, let's see, let's go ahead and switch this to 0 so it's always on. I'd say I apologize for this, but this is actually good practice. This is what you see me do when I'm running around the class trying to help people. I go the same thought process, try to break it down into pieces of what chunks could be wrong, and then each one I kind of attack one at a time. Alright, so man, it is on, so that helps us, but we got a weird flicker. I'm going to pull this wire out now and just put a different one in. I know that's the problem, but let's give it a try. Still very dim. Is it going out when I do that? Did I grab the wrong resistor? Let's pull that out and check that with my multimeter. I'm going to swing my multimeter in here so you can see what I see. I'm going to test my resistor here, make sure it's the right size. Nope, 330, so that's good. Interesting. I mean, otherwise it seems to be working, but I don't know why it's flickering like that. You can't see it very well on the video, but maybe I can tilt this way or something. Yeah. Why are we flickering? We know this is working fine because we built that beforehand. Let's move this over a little bit. That's steady. I'm going to take this out and move this straight over and just skip that. That is interesting. Let's go back to the 5 volts again. Oh, nice and bright, like that. Oh, I think I know what it is. I think I know what it is. Just dawned on me. It's not a wiring problem. Sorry, that took a while. I think the flicker, actually it's steady now. I think the flicker, no, because it's on 0 the whole time. I was thinking that perhaps it was because we're jumping out of this and going low or turning on and off really fast. But all we're reading is zeros. What if I took that out? Take out our low. I know this seems like a pain and everything, but actually this is probably, besides getting the projects to work properly, I think one of the most satisfactory thing I have with doing this stuff is when there's problems and trying to figure them out, and then you get them right, and you're like, hey, I figured this out. That's cool. So let's try this again. Now it's staying on the entire time. Did I not put this back into 7? I did. Yeah, it's staying on because I'm not turning it back off. But we're back to being bright at least.
Faculty, if you have a chance, please stop by the faculty room to congratulate Shayna and her new little baby. There's a treat in there, and she's in there with gifts.
I'm going to go ahead and do this, and this might solve the problem. I think it still might be going on and off. That's why I had the flicker. But I'm going to go ahead and wire this other LED up, because that way I'll have a state for each one that's well defined, which I'll show you in just a minute. I'll be curious to see if that solves the problem. So I'm going to send this one, oh, I need my resistor, and we'll send it to the negative, like that. That looks pretty good. The other side, let's send it to 6. Alright, let's add a little bit of code in here. Let's bring this part back. We can use it. We're going to have a state for both the on and the off. So based upon the tilt switch, we're going to have this be 1, and let's make this be digital right. We used 6 for that one. Make that go off, and then on this one, let's have this one, the 6, which is the red one, digital 6B high. Alright, so it can only be 0 or a 1. That's what we're going to get from the tilt switch. And if it's 0, we'll always have pin 7 be high, which will be the green one. And then if it ever goes to a 1, then we'll send the green, we'll turn it off, and then we'll turn on the red one. That way we don't have this strange jumping out of the loop and turning itself off, like I think was the problem. So let's give this a try. Ooh, we got another error. Alright, it looks like I left out a bracket. This bracket goes with this one, but the entire loop needs a closing one. So let's re-upload. See if it's happier now. Looks like it's happy. I'm going to turn the serial monitor on so we can see what state we're in. Alright, so that's green. And we'll tilt it. And the other one's not going. It's going to a 1. But the other one's not turning on. Now we don't know for sure that the red one's working, I suppose. So I'm going to grab a different one. Pull that one out. You never know. Let's just try that one. No, that's not it. Let's check my wiring out again. I'm just going to make it go on by giving it a on, and it's happy with that. Oh, you know what I forgot to do? I thought I saw a little bit of light coming on there, but it was dim. Yes. Matter of fact, when I tilt it, there's no way you can see this on the video, but it's barely on. So I think this is a good example, what I mentioned at the beginning of the video. Mr. Brower forgetting when he adds some new pins, he's got to tell the Arduino what's going on, especially when it's output. All right. Here we go. I think this will do it. Run 0 and it flicks to 1 on the serial monitor, and that causes the actually you didn't even get to see the first one because it was off video there. That went red. It looks good. To the back, green. How about that? And we could even probably just tap this thing and it'll flick over to the other side. Every time I tap it, it goes to the 1. Okay, well, that was interesting. Had a lot of little problems there, but we did work them out. We just broke it down into pieces and tried to solve each one at a time. And hopefully you won't have any problems. Well, actually, I hope you have some problems, but that you can at least fix them yourself, because you'll learn more from the errors you make. Okay, this looks nice. All right, we're going to end there, and we'll see you in the next project.